Everything feels stable, solid, predictable. The ground beneath you doesn't suddenly disappear. The objects around you stay where they are. If you drop something, it falls. If you push something, it moves. The world follows rules, clear, consistent, reliable rules. And because of that, you trust it. You trust that reality behaves the way it appears, that objects exist in definite places, that things are either here or there, not both, that what you see is what is actually happening. It feels obvious. So obvious that you never question it. But here's where things start to break, because the reality you trust is not the reality that physics actually describes. At the scale you experience, the human scale, everything behaves in a clean, logical way. But when scientists began to look deeper, far beyond what your eyes can see, they discovered something unsettling. The rules change. Not slightly, completely. At the smallest level of reality, inside atoms, inside particles, the world stops behaving the way you expect. Look around you. Everything feels stable, solid, predictable. The ground beneath you doesn't suddenly disappear. The objects around you stay where they are. If you drop something, it falls. If you push something, it moves. The world follows rules, clear, consistent, reliable rules. And because of that, you trust it. You trust that reality behaves the way it appears, that objects exist in definite places, that things are either here or there, not both, that what you see is what is actually happening. It feels obvious. So obvious that you never question it. But here's where things start to break, because the reality you trust is not the reality that physics actually describes. At the scale you experience, the human scale, everything behaves in a clean, logical way. But when scientists began to look deeper, far beyond what your eyes can see, they discovered something unsettling. The rules change. Not slightly, completely. At the smallest level of reality, inside atoms, inside particles, the world stops behaving the way you expect. Things don't have fixed positions anymore. Objects don't follow clear paths, and cause and effect begin to blur. The solid world you rely on begins to dissolve, and in its place something far stranger appears, a reality where certainty disappears, a reality where things can exist in multiple states at once, a reality that doesn't just challenge your intuition, it breaks it. And the most unsettling part, this strange, unpredictable world is not separate from your reality. It is the foundation of it. Everything you see, everything you touch, everything you believe is solid and real, is built on top of these rules. Rules that don't behave the way reality is supposed to behave. So now you're left with a question. If the foundation of reality doesn't follow the rules you trust, then how real is reality, really? At the quantum level, the rules you trust don't just bend. They break. Imagine this. You fire a tiny particle, something like an electron, toward a barrier with two small openings. Logically, it should behave like anything else. It should go through one opening or the other, but that's not what happens. Instead, it behaves like a wave. Not a solid object choosing a path, but something that spreads out, passes through both openings at the same time, and interferes with itself like ripples in water overlapping and creating pattern. One particle, two paths at the same time. That shouldn't be possible, and yet it is. This is called superposition, the idea that a particle doesn't have a single definite state until something forces it to have one. Until then, it exists in multiple possibilities at once. Not one or the other. Both. Now think about what that means. In your everyday world, something is either here or there. It's either moving or still. It either exists in one state or another. But at the quantum level, those clear distinctions disappear. Reality becomes a set of probabilities. Instead of saying the particle is here, physics says the particle has a probability of being here. That's not just uncertainty in measurement. It's uncertainty in existence itself. And it gets even stranger. When you try to observe the particle, when you measure which path it took, it suddenly behaves differently. The wave-like behavior disappears, and it acts like a single object again, as if the act of observing forces it to choose. Before measurement, it was many possibilities. After measurement, it becomes one. So now you're left with something deeply unsettling. Reality doesn't behave like a fixed system waiting to be discovered. It behaves like something that only becomes definite when you interact with it. And that's the moment where physics stops feeling like a description of realities and starts feeling like a challenge to it. Now, here's where things take an even stranger turn. It's not just that particles behave like waves, it's that your attempt to observe them changes what they do. Go back to that experiment, the one where a particle passes through two openings. When you're not looking, it behaves like a wave. It spreads out, goes through both paths, interferes with itself. But the moment you try to find out which path it took, everything changes. Suddenly, the particle acts like a particle again. It chooses one path. The wave-like behavior disappears completely, just because you looked. At first, that sounds unbelievable. It feels like observation is somehow controlling reality, like your act of measuring is forcing the particle to decide what it is. But here's the deeper idea. In quantum physics, observation, that doesn't necessarily mean a human watching. It means interaction. Any attempt to measure, detect, or gather information about a system changes that system. You cannot observe something without affecting it. And at the quantum level, that effect is not small. It's fundamental. Before measurement, the particle exists in a spread of possibilities, a superposition. But when you measure it, you force it into a single outcome. Not because you chose it, but because interaction collapses the possibilities into one reality. And that leads to a disturbing implication. Before you measure something, it doesn't have a definite state. Not hidden, not unknown, undefined. Reality itself is not fully formed until interaction happens. That's a completely different way of thinking about the world, because it means the act of observing is not passive. It's active. It participates in shaping what becomes real. And once you understand that, the line between observer and reality starts to blur. You are no longer just watching the universe. You are part of the process that defines it. By now, the idea of reality being stable and predictable has already started to crack. But quantum physics doesn't just crack it. It completely reshapes it. Take superposition. For example, a particle can exist in multiple states at once, here and there, moving and not moving, until something forces it into one outcome. That alone challenges everything you thought you knew. But then comes something even stranger: entanglement. Two particles can become linked in such a way that whatever happens to one instantly affects the other. Even if they are separated by vast distances, not seconds later, not after a signal travels between them, but instantly. That means information, or at least influence, seems to move faster than anything should be able to, faster than light, and that shouldn't be possible. Because according to everything else we know, nothing can travel faster than light. That's a fundamental limit of the universe. And yet the entanglement appears to ignore that limit entirely. It's as if the two particles are not really separate at all, as if distance doesn't fully apply to them. This is where reality becomes difficult to picture. Because the world you're used to is built on separation, objects here, other objects there, space in between. But at the quantum levels, that separation becomes blurry. Particles can be connected in ways that don't make sense in classical terms. And then superposition means they don't even have a single definite state until something interacts with them. So now you have a picture of reality that looks nothing like the one you started with. Objects are not always in one place. That's all. States are not always fixed. Connections are not limited by distance. And certainty is replaced by probability. This isn't just a strange corner of physics. This is the foundation. Everything you see, everything solid, stable, and predictable, is built on top of these rules. Rules that don't behave the way reality is supposed to behave. And once you realize that, the question is no longer why is quantum physics strange? The real question becomes, why does the world look normal at all? At this point, the question is no longer about particles or experiment. It's about reality itself. Because if everything you've just seen is true, if particles don't have definite states, if observation affects outcomes, if connections ignore distance, then the world you experience every day is not what it seems. It's a simplified version. Stable illusion built on top of something far less stable. Think about it. You see solid objects. You trust that they exist in fixed positions. You believe that reality is consistent, continuous, and independent of you. But at the quantum level, none of that is strictly true. Things are not always defined. They are not always separate. They are not always predictable. So what is real? Is it the definite world you experience, or the probabilistic world that actually exists underneath it? Because both seem true in different ways. Your everyday reality is reliable. It works. It allows you to function, to interact, to survive, but it's built on a deeper layer that doesn't follow the same rules. A layer where certainty disappears, and that creates a strange possibility. Maybe reality is not a single thing. Maybe it's layered. What you experience is one version, clear, stable, easy to understand, but beneath it is something more fundamental, something abstract, something that doesn't fit into your usual way of thinking, and you only glimpse it when you look closely enough, that's what quantum physics does. It doesn't destroy reality. It reveals that reality is more complex than it appears, that what feels solid may be built on uncertainty, that what feels separate may be deeply connected, and that what feels definite may only become definite when you interact with it. So when you ask, what is real? You're not asking a simple question anymore. You're asking where the boundary is between what you experience and what actually exists.